Hello everyone, welcome to my channel InstaMaths. Today in this video we will be doing problems on vector algebra and we will be doing exercise 10.2 from NCERT book. Okay, so let's start and see the questions from exercise 10.2. So let's see the first question, that is we'll have to find the magnitude of the given vectors. Okay, so I have taken two sub questions, more questions are there, you can do it yourself. If you can do one or two questions, then you can do the others also. So the first one I have taken, the vector is let me represent by a vector. Okay, so a vector is I j k. Okay, I plus j plus k. So I want to find the magnitude of a vector. I have represented it by a vector. So magnitude of a vector is, it will be, if this a is a vector, then its magnitude is denoted by mod of a. Okay, and it is equal to what? It is equal to the scalar component of I square, that is 1 square, along with I have 1, so 1 square, plus along with j I have 1, so 1 square, plus along with k I have 1 scalar, so 1 square. So this will give you the magnitude of the vector a. So it is what? 1 plus 1 plus 1 will be, it will be 3, that is root 3. Okay, since we know that if a vector is denoted by xi plus yj plus zk, then its magnitude is nothing but root over x square plus y square plus z square. Okay, so I have used that formula only. So similarly we can do the second one, that is, it will be let me consider it b vector. So b vector is 1 by root 3 I plus 1 by root 3 j minus 1 by root 3 k. So I am doing the second question. So its magnitude will be given by mod of b vector, and it's nothing but, along with I have a scalar component, that is 1 by root 3, so it will be 1 by root 3 whole square. Along with j I have 1 by root 3, so 1 by root 3 whole square, plus along with k I have minus 1 by root 3, so minus 1 by root 3 whole square. So this will give you 1 by 3 plus 1 by 3 plus 1 by 3. Okay, so I will be getting what? 3 by 3, isn't it? That is root 1, that is 1. So answer will be 1 only. So similarly you can do more questions on this. This is very simple, how to find a magnitude of a vector. Any vector you can use this formula and find the magnitude of it. Okay, so let us see the next question. So next question is write two different vectors having same magnitude. Okay, so we'll have to write two different vectors which have the same magnitude. So there are many examples. You can write any two vectors which have same magnitude. In different vectors you can write. Okay, so let me take a vector. A vector is equal to, say for example, I plus 2j plus 3, just let me write 3k, yeah, 3k, and b vector is equal to, let me change the components, the scalar components of the ijk vector, just change it. So let me write here 2i plus, say for example I am writing here j, and there I am writing k. Okay, so what I am doing here, just I am changing the scalar components. It was 2 was with j, but now I am writing 2 with I. Okay, and with I had 1, now I am writing with j 1, isn't it? Nothing is there means 1. So these are two different vectors, you can see. Now you see here, if I find the magnitude of a vector, it will be what? 1 square plus 2 square plus 3 square, isn't it? So it will be what? 1 plus 4 plus 9, that is, it will be 14, root 14. Similarly, if I find the magnitude of b vector, then it will be 2 square plus 1 square plus 3 square, and this will be again 4 plus 1 plus 9, so it will be root 14. So we can see that a and b are two different vectors, but they have the same magnitude, isn't it? So therefore I can write a and b are two different vectors, having same magnitude. Okay, so two different vectors having same magnitude. So by shifting the scalar components here and there, you can get different vectors, isn't it? But the scalar component must be there, so that after squaring you will get the same value of magnitude. So in that way we can write many examples like that. Say for example, if I am writing here 5, 6, 7, say for example I am writing here 5, 6, 7, then I will shift the numbers. Let me write 7, 6, 5 like that in the next vector. So they will become different vectors, isn't it? So this is very easy. Hope you have understood. So let us see the next question. So let's see this question. Next question is write two different vectors having the same direction. Now we are looking at direction. Okay, so here whenever we come across the word direction, so if two vectors are having the same direction, then they must have the same direction cosines. Okay, so you will have to write two vectors in such a way that they are having the same direction cosines. So let me take two vectors. Let a is equal to, say for example I am taking I, j, k only, I plus j plus k only, and say b vector is 2i plus 2j plus 2k. Okay, so these two vectors are different. Okay, let me find the direction cosine. So we have already seen that the direction cosine of a vector, how it is found, the I component, whatever, if say for example x plus y, xi plus yj plus zk is the vector. Okay, then how to find the direction cosine? You will have to write the I component divided by the magnitude of the vector. Here r is what? R is magnitude of the vector. So x divided by r, I component divided by the magnitude of that vector, j component divided by the magnitude of that vector, okay. Likewise z, k component, okay, k component z divided by the magnitude of the vector. So this gives the direction cosines. Okay, so if I find here for a, this is, I am writing in short form, direction cosines of vector a r, it will be what? Here nothing is there means 1 is there, so 1 by what will be the magnitude of vector a? It will be root 3, isn't it? Here along with j I have 1, so 1 divided by magnitude of that vector is root 3. Along with k I have 1 divided by magnitude of the vector is root 3. Okay, you can find a magnitude of a, isn't it? Magnitude of a will be what? Root 3, you can find it. Similarly, if I will do for direction cosines of b vector, then I will be getting, along with I have what? Along with I have 2, and what will be the magnitude of this? If I will find the magnitude of b vector, it will be root over 2 square plus 2 square plus 2 square, isn't it? So 4 plus 4 plus 4 plus 4, so it's 12, root 12, that is 2 root 3. Okay, so it's 2 root 3. So direction cosine formula is what? The I component divided by the magnitude of that vector. Magnitude of the vector is 2 root 3. Similarly, j component divided by scalar component divided by magnitude of the vector. Likewise, k component, that is the scalar component of k, it will be divided by magnitude of the vector. So what we are getting, if we simplify, it will be 1 by root 3, 1 by root 3, 1 by root 3. So this direction cosines are for vector A and this direction cosines are for vector B. Okay, they are equal, they are same, and for this reason we can tell that A and B are having the same directions, but they are different vectors. Okay, so we can conclude like that. Therefore, A and B are two different vectors having same directions. Okay, so it's simple. You can take anything, any vector multiplied with a, if any vector you are multiplying with a number, whatever you will be getting, that one you take it another vector. I have taken here I j k vector, I plus j plus k vector. So what I have done there, I have multiplied by 2, so that vector becomes a different vector, isn't it? So similarly, you can take many examples, different examples in the same process. Okay, so let's see the next question. So the next question is find the values of x and y so that the vectors this and this are equal. Okay, so it's given that 2i plus 3j, this vector is equal to xi plus yj. Okay, so they are equal, it's given only. So if they are equal, if I compare both sides, comparing both sides, okay, 2 is equal to x. If I will compare, 2 will be equal to x, and if I will compare here, the j component is y, j component is 3, so 3 will be equal to y. So therefore I have got x is equal to and y is equal to 3. So this is the answer, very simple. So let's see this question. Okay, so here we have been given 2 points. Okay, so let A 2 1 and B minus 5 7 be the given points. I have taken A and B. Okay, so here A is the initial point and B is the final point. Okay, so initial point is 2 1 and final point is minus 5 7. Okay, so find the vector and scalar components of the vector with initial point 2 1 and terminal point minus 5 7. So by considering initial point A and final point B, I will have to find the vector, and the vector which I will be getting, its vector components I will have to write and its scalar components I will have to write. So first of all, let us find the AB vector. Okay, 2 points. By taking 2 points, we know how to find the vector. Okay, so AB vector is nothing but, we have the formula, position vector of B minus position vector of A, isn't it? So position vector of B will be what? Any point, if it is given, you can write the position vector by including I, j like this. Okay, and adding them. So here the z component is not given, that's why we will write 5i minus 5i plus 7j like that. Similarly for this one also. So position vector of point B will be what? Minus 5i plus 7j. Okay, similarly position vector of point A will be 2i plus j. So if you will subtract, what you will get? Minus 5i, here it will be minus 2i, that is minus 7i, and here plus 7j minus j will be 6j. So I have got the vector. Okay, now its vector component I will have to write and its scalar component I will have to write it. Okay, so therefore vector components are minus 7i and 6j. So these are the vector components. Okay, I have a vector and their vector components are minus 7i and minus 6j, and scalar components will be what? Scalar components will be it will be minus 7 and 6. So scalar, the word scalar itself tells that it will be constant only. So these are the scalars, minus 7 and 6. So these are the scalar components, and if I will include I, j like that, they will become the vector components. Hope it is clear. So let's see the next question. So next question is find the sum of the vectors. So it's very simple, just you'll have to add it. Okay, so if I want to find the sum of the vectors a, b, c like that, then what you will do? A plus b plus c is equal to, just you'll have to add it. Write the vectors I minus 2j plus k. Okay, after that plus minus 2i plus 4j plus 5k. Okay, after that plus I minus 6j minus 7k. Okay, so just add it and you will get the answer. So just normal addition. I minus 2i will be minus I plus I will be 0i. So I am not writing, let me write it only. 0 I have got, 0i. Minus 2j plus 4j will be 2j minus 6j will be minus 4j. Okay, likewise k, 5k, 6k minus 7k will be minus k. So your answer will be minus 4j minus I. So this is the answer after addition. It's very simple, just normal addition only. So let's see this question. Find the unit vector in the direction of the vector I plus j plus 2k. Okay, so a vector is given, I want to find the unit vector of it. Okay, so the question may be asked like this also, find the unit vector of this vector like that, or find the unit vector in the direction of the vector. So same thing only, you'll have to find the unit vector. Okay, so given vector is what? Given vector is a vector is equal to I cap plus j cap plus 2k cap. Okay, so this is the given vector. I want to find the unit vector of it. Therefore unit vector of a bar is, it is given by the formula a cap is equal to a bar by magnitude of a bar. Okay, so this is the formula of any unit vector, vector. This is the formula. If a is any vector, then the unit vector will be denoted by a cap and it will be given by a bar by magnitude of a bar. Okay, so here just substitute the value. Okay, magnitude of a bar will be what? 1 square plus 1 square plus 2 square. So it's I plus j plus twice k divided by 1 plus 1 plus 4, that is root 6. So I can write like this also, 1 by root 6 I, 1 by root 6 j plus 2 by root 6 k. Like this we can write it, or you can write like this also, 1 by root 6 into I plus j plus twice k. Like that also we can write. Okay, so this is the unit vector of the given vector A. So similarly you can do any unit vector. Okay, if a vector is given, you can find the unit vector of that vector by using this formula. Okay, So the next question is find the unit vector in the direction of the vector PQ vector. Okay, PQ vector. Find the unit vector in the direction of the PQ vector where P and Q are given. Okay, so by using the points P and Q, we will find PQ vector. Okay, so first of all, let me write given points. Given points are P 1, 2, 3 and Q 4, 5, 6. So these points are given and we'll have to find the PQ vector. So if I want to find PQ vector, I will have to use the formula, that is position vector of Q minus position vector of P. So we know the formula. If AB is there, first of all we'll have to write position vector of B minus position vector of A. Likewise, here also we have done. So position vector of Q will be what? I have told only, just apply I, J, K along with that numbers and add it. That will be the position vector of that point. Minus position vector of point P will be what? I, 1I means I only, plus 2J plus 3K. Okay. After that you subtract 4 minus, it will be, minus will be multiplied everywhere. No, that's why I am doing directly. 4 minus I will be 3I, 5 minus 2 will be 3J, 6 minus K will be 3K. So this is the vector, PQ vector. Okay. Now I want to find the unit vector along this vector in the direction of this vector. Okay. So therefore the required unit vector in the direction of PQ vector is, we can write PQ cap also like this. Okay, so PQ vector was there, so I am writing PQ cap. So that is the notation of unit vector. So it will be PQ bar by magnitude of PQ vector. Okay, so this is the formula. Just substitute the values there. It will be what? PQ vector is 3I plus 3J plus 3K. So divided by the magnitude of the vector will be what? 3 square plus 3 square plus 3 square, isn't it? So it will be, let me take 3 common here above. If I will take 3 common, it will be 3 into I plus J plus K. And below it, what I will be getting? I will be getting 9 plus 9 plus 9, isn't it? That is 27. So it will be what? 3 by 3 root 3 I plus J plus K. So it will be 1 by root 3. It will be 1 by root 3. Yeah, I plus J plus K. So this will be the answer. So let's see next question. Next question is for given vectors A and B, find the unit vector in the direction of A plus B. Okay. So what you will have to do here is find A plus B. Okay. In this question, you first of all find A plus B. If you will add these two vectors A and B, okay, then you will be getting A plus B vector. Okay. So whatever you will get vector, its unit vector you will have to find. Okay, A plus B vector you will be getting a vector and its unit vector you will have to find. Okay, so like before only you can do it. Just consider, suppose that this vector is equal to C vector, you can take let it be C vector like that, and you will have to find C cap, that is C bar by magnitude of C like that. So you can do it that one. So do it yourself. Let me see the next question, that is find a vector in the direction of the vector this. So in this direction I want to find a vector and it has magnitude 8. It should have magnitude 8 units. Okay. So what we will do here is whatever vector is given, okay, let me consider a vector. Okay, I want to find another vector which is in the direction of this vector only and has magnitude 8 units. So its direction, if I want to find, first of all I will find the unit vector of it. Okay, so I will get its direction. Always unit vector will give the direction. You just see, while finding direction cosines, what we were doing, we were doing I component divided by the magnitude, isn't it? X by r, y by r, z by r, like that. So actually, while doing the unit vector also, while finding unit vector also, we are doing the same thing only. Just you can see magnitude vector divided by the magnitude. Okay, so at that time, what will be the components of the unit vector? That will be the direction cosines only. There will be nothing but the direction cosines only. That's why here, in order to find the direction of a vector, you will have to find the unit vector. So I will find the unit vector of this vector and I will multiply 8. I will multiply 8 with that vector, unit vector. Then I will get a vector having magnitude 8 in the direction of this vector. So let's do it. So first of all, I will find unit vector of this vector. So this will be what? A vector by magnitude of a vector. So it will be 5i minus j plus 2k. Okay, let me do it directly. It will be 25 plus 1 plus 4. So this will be 30, isn't it? So 5i minus j plus 2k divided by 30. So I have got the unit vector, this. Okay, this is the unit vector. Now I want to find a vector having magnitude 8 and is in the direction of this vector. So I have found the direction. Okay, so what required vector will be what? Therefore the required vector is nothing but 8 into a cap. Okay, required vector will be what? 8 into a cap. A cap is the direction of, means it gives the direction of a bar, isn't it? So I want to find a vector which is in the direction of a vector and having magnitude 8. So this will be 8 into 5i minus j plus 2k divided by 30. So this will give you what? 8 by 30, 5i minus j plus 2k. So this is a vector which is in the direction of a vector and having magnitude 8. If you will find the magnitude of this vector, okay, if you will find the magnitude of this vector, then you will get answer 8 only. You can just check it, you will get answer 8 only. Okay, so let's see the next question. Now let's see this question. Show that the vectors this and this are collinear. We'll have to show they are collinear. Okay, so we know that a and b, two vectors a and b are said to be collinear. Two vectors a and b are said to be collinear if either we can write if a is equal to lambda b or b is equal to lambda a. If we can write in this form, if one can be written in terms of the other, okay, then we can say that the vectors are collinear. Okay, either a is equal to lambda b we can write, or b is equal to lambda a, where lambda is a constant or scalar. Okay, so here let me take a is equal to twice I minus 3j plus 4k. Okay, and b is equal to, b vector is equal to minus 4i plus 6j minus 8k. Okay, now if I see then I can see that b can be written like this, 4i plus 6j minus 8k like this, and I can take a common minus 2 from it. Okay, then b can be written minus 2 into twice I minus 3j plus 4k. So if I will take a minus 2 common from b, then I am getting a vector inside it, and this vector is nothing but this is the a vector, isn't it? It is the a vector. So I can write minus 2 into a vector. So therefore I have got b is equal to minus 2 into a vector. So it is of the form b is equal to lambda I, isn't it? So therefore I can write a and b are what? Collinear. And b are collinear. In case of parallel also, okay, two vectors are parallel or not. If you want to check, you can go for this formula also. Okay, if two vectors are parallel, you can write a is equal to lambda b or b is equal to lambda I. In that case also it will be true. So let's see the next question. So let's see these questions. Find the direction cosine of the vector this. Okay, so I want to find a direction cosine of the vector. Here also in the next question also you are going to find a direction cosine of the vector joining these 2 points. Okay, so by using these 2 points I will find a vector, a b vector, and whatever vector I will be getting, its direction cosine I will be finding. So these 2 questions are similar only. Here the vector is given directly, I will have to find the direction cosine of it. Here I will have to find the vector, after that only I will have to find the direction cosines. So let me do this question only, 13. Okay, and similarly you can do it 12 also. So here the given points are a 1 2 minus 3 and b minus 1 minus 2 1. Okay, so here I will have to find the vector first of all, a b vector. In that question number 12, no need to find the vector, it's already given. Directly from that vector only you will have to find the direction cosine. But here I want to find the I have to find the vector first of all. So a b vector is what? Position vector of b minus position vector of a. Okay, so position vector of b will be what? Minus I minus 2j plus k, isn't it? Minus position vector of a will be I plus 2j minus 3k. So if I will subtract minus I will be minus 2I minus 2j minus 2j, yeah, it will be minus 4j, and plus k minus 3k, minus plus, so 4. So if I will subtract this, I will get minus 2I minus 2 minus 2 will be minus 4j, after that plus k minus plus 3k, so that is 4k. So I have got the vector, that is AB vector. Okay, now I want to find the direction cosine of this AB vector. So we know that in order to find the direction cosine of a vector, what we do, if a vector is given, say for example r is equal to xi plus yj plus zk, say for example, then its direction cosine is what? I component, x is there, so x by the magnitude of that vector, y by magnitude of the vector, and z by magnitude of the vector, like that. So I component divided by magnitude of the vector, j component divided by the magnitude of the vector, and k component divided by the magnitude of the vector. So this thing if we do, it will give the direction cosines. Okay, or if you want to find the unit vector, then from unit vector also you can get the direction cosines. First of all, find the unit vector, and the I component, j component, k component will give you the direction cosines. So like this also you can do it, or first of all find the unit vector of the vector, and the components of the unit vector will be the direction cosines. Likewise also you can do it. So here if I want to find the direction cosine of this vector, first of all let me find the magnitude. Magnitude of this will be what? Minus 2 whole square plus minus 4 whole square plus 4 square, isn't it? So it will be how much? It will be 4 plus 16 plus 16, that is 36. Root 36 will be 6. So I have got the magnitude. Okay, so therefore the required direction cosines of AB vector are, it will be what? AB vector I component is what? Minus 2 divided by its magnitude. Magnitude is 6. J component is minus 4 divided by magnitude of that vector is 6. K component is 4 divided by the magnitude is 6. So it will be how much? Minus 1 by 3. This will minus 2 by 3 and 2 by 3. So this is the direction cosine of the vector AB. Okay. So I mean to say that if you are directly finding the unit vector, if you are finding unit vector of AB, at that time whatever vector you will be getting, its I component, okay, I component, J component and K component, whatever you will be getting, I, J, K components, those components will give you the direction cosines. In that way also you can do it, I mean to say that. Okay. So let us see the next question. So let us see this question, that is show that the vector I plus j plus k is equally inclined to the axis OX, OY and OZ. Means it is equally inclined with x axis, y axis and z axis. We want to show that. Okay. So if you are asked that whether it is equally inclined or not, a vector is equally inclined or not, then what you will have to do? You find the direction cosines and see whether the direction cosines are all same or not. If they are all same, equal, then we can tell that the vector is equally inclined with x axis, y axis and z axis. Okay. So here let me take the given vector A vector I plus j plus k. Okay. Let me find its direction cosine now. So just now I have told you how to find a direction cosines. Just divide the I component, j component, k component by its magnitude, you will get the direction cosine, isn't it? Or find the unit vector of it and the components will give you the direction cosines. Okay. So let me find the unit vector of it. Here a cap will be what? A bar by magnitude of a bar, that is I, j, k divided by magnitude of a bar will be 1 square plus 1 square plus 1 square. So this will be I plus j plus k divided by root 3. So it is 1 by root 3 I, 1 by root 3 j and 1 by root 3 k. Okay. So just now I have told you the magnitude of the the components of the unit vector, I component, j component and k components of the unit vector. Okay. They give the direction cosine of that vector. So therefore DC's are what? DC's are 1 by 3 direction cosines. Okay. Direction cosines are 1 by 3, 1 by root 3, 1 by root 3, 1 by root 3. So since the DC's are all equal, so the vector A is equally inclined with the coordinate axis or with the axis OZ, OX, OY and OZ. Okay. So since the DC's are all equal, okay, since the DC's are all equal, so the vector A vector is equally inclined with the axis OX, OY, OZ. So it's proved. Okay. Let's see the next question. So let's see the next question, that is find the position vector of a point R which divides the line joining P and Q, okay, whose position vector are this and this, it's given. Okay, in the ratio it divides the line joining PQ in the ratio 2:1, it's given, and we'll have to find the position vector of R whenever it is dividing internally as well as externally. So first of all, let me write whatever is given. So let me take A bar is equal to I plus 2j minus k be the position vector of point P. Okay, and let B be the B is equal to minus I plus j plus k be the position vector of point Q. So I have taken the position vectors A and B. Okay, now I want to find the position vector of point R which divides the line joining PQ in the ratio 2:1 internally and externally. So let R be the position vector of point R which divides PQ in the ratio 2:1 internally. Okay, so first one I am taking. Then therefore by section formula the position vector of R will be what? Position vector of R will be what? I have taken R bar and it will be given by R bar is equal to, if I draw, if it is P and Q, then say for example this is the point R, its position vector is A and its position vector is B. Okay, and R is dividing PQ internally in the ratio 2:1. Okay, so we know that if this is M, this is N, so M into B plus N into A divided by M plus N is the formula. MB plus NA divided by M plus N is the formula for the position vector of the point R, isn't it? We have got that formula already. Now I will use that formula. So R will be what? This 2 will be multiplied with this vector and 1 will be multiplied with this vector divided by 2 plus 1. So it is what? 2 into B vector plus 1 into A vector divided by 2 plus 1. So this will be the position vector of the point R which divides PQ, the line joining PQ or PQ, in the ratio 2:1 internally. So just we will have to solve it, we will get the answer. So if I will continue, then I will get what? 2 into B. B is minus I plus j plus k, and 1 into A will be A only. So I am writing just the A vector here divided by 2 plus 1, that is 3. So here what I will get? Minus 2I plus 2j plus 2k plus I plus 2j minus k divided by 3. So here what I will get? Minus 2I plus I will be minus I, 2j, 4j, 2k, and minus k will be minus plus k divided by 3. So this will give you the vector minus 1 by 3 I, 4 by 3 j, and 1 by 3 k. So this is the position vector of the point R which divides PQ in the ratio 2:1 internally. Okay, you can leave it like this also. Now let us see the position vector of the point R which divides the line PQ in the ratio 2:1 externally. Okay, so let's see that one. For number 2 also, let R bar be the position vector of the point R which divides PQ in the ratio 2:1 externally, okay, externally. Then bisection formula, the position vector of point R is R bar is equal to, we have the formula like for internally it was m into b plus n into a divided by m plus n, isn't it? So now for external what we will do, just we will write in place of plus minus, okay. So it will be 2 into b minus 1 into a divided by 2 minus 1. So I will be getting here 2 into b is this one, so I am directly multiplying. I will get minus I twice I plus twice j plus twice k, okay, minus 1 a. So a is what, I am directly multiplying the minus sign to minus 2j plus k divided by 1. So I have put the values and directly I have done it, okay. So I will get 3i minus 3i, here it will be 0j, it will be 0 only, no need to write, but I am writing. So it will be 2k plus k will be 3k divided by 1. So it is nothing but 3i plus 3k. So this is the answer. So this is the position vector of the point R which divides the line PQ in the ratio P 2:1 externally, okay. So let's see the next question. Find the position vector of the midpoint of the vector joining the points this and this, okay. 2 points are given and we'll have to find the midpoint joining P and Q, okay. So here P is there, Q, so P and Q are there. So I want to find the midpoint, the position vector of the midpoint, okay. Say the position vector of point P is A, position vector of point Q is B, okay. So I am writing here, let A bar is equal to twice I plus thrice j plus 4k be the position vector of P 2 3 4, and let B is equal to 4i plus j minus twice k be the position vector of Q 4 1 minus 2. So points are given, I am writing the position vector, okay. By using the points only I have written the position vector, by using the points only I have written the position vector, okay. So I have written the position vectors. Now I want to find the midpoint R, okay. So the position vector, therefore the position vector of the midpoint R of the line joining PQ, P and Q is, I am denoting it by R bar, okay. So R bar, I am denoting it by R bar. So if this is the midpoint, then the ratio will be 1:1, is not it? So 1 will be multiplied there, here also 1 will be multiplied and divided by 1 plus 1, that is a plus b by 2, it will be a plus b by 2. So if you want to follow the section formula, then you can follow it, or if you want to find a midpoint, just add the two vectors and divide by 2. That is also the way to find the midpoint, midpoint, yeah. So here I want to find the position vector of the midpoint. So similarly I will do 1 into b, that is b only, plus 1 into a, that is a only, divided by 1 plus 1 will be 2. So it's like we are adding the two vectors and dividing it by 2 only. So that will be the position vector of the midpoint. Okay, so here what I will get, directly I am adding, okay, a and b. It will be 6i, it will be 4j plus 4j, and it will be plus 2k divided by 2. So I will get 3i plus 2j plus k. So this will be the position vector of the midpoint. Okay, so let's see this question. So show that the points a, b, c with position vectors vector a, vector b and vector c respectively form the vertices of a right angled triangle. We want to prove that the position vectors of the point form the vertices of a right angled triangle. We will have to prove that. So if I have a vector, so let's see the next question, that is, show that the points a, b, c with position vectors vector a, vector b, vector c respectively form the vertices of a right angled triangle. Okay, the points a, b, c are the vertices of a right angled triangle. We will have to prove it. So let me take a triangle a, b, c. Okay, here for point a the position vector is a bar, for point b the position vector is b bar, for point c position vector is c bar. Okay, so we want to prove that this triangle is a right angle triangle. So here given position vector of point a is a bar is equal to 3i minus 4j minus 4k. Position vector of b is b bar is equal to twice I minus j plus k. Position vector of point C is C bar is equal to I minus 3j minus 5k. So these are given. Okay. Now in order to prove whether this triangle is right angle triangle or not, how we will have to prove it? Just we will find the sides, okay, sides AB, BC and AC, and we will see whether the sum of the square of two sides is equal to the square of the third side or not. Means it is following the Pythagoras theorem or not. If it is following the Pythagoras theorem, then we can say that the vertices will be the vertices of a right angle triangle. Okay. So first of all I will have to find the sides AB, BC and AC. So in order to find the side AB, first of all I will have to find the vector AB. So vector AB is what? Position vector of B, isn't it? Position vector of B minus position vector of A. So this is nothing but it will be position vector B is B, position vector of A is A. So if I will subtract, directly I am doing, if I will subtract, I will get minus I minus it will be plus 3j plus 3j. After that 1 minus 4 will be plus 5k. So I have got AB vector is this. So I want the side, is not it, AB. So AB is nothing but what? AB is the magnitude of the vector, is not it? So it will be minus 1 whole square plus 3 square plus 5 square. So it will be root over 1 plus 9 plus 25. So this is 35, root 35. So AB I have got root 35. So therefore AB square will be what? AB square will be 35. So similarly we will have to find BC, AC also. Okay. So let's see BC vector. So BC vector will be what? BC vector will be position vector of C minus position vector of B. So C minus B, that is 1 minus 2 will be 1 minus 2 will be minus 1 I, minus 3 minus plus 1 will be minus 2j, and minus 5 minus 1 will be minus 6k. So I have got this. Therefore BC will be what? BC vector modulus magnitude of BC vector. Okay, so it will be minus 1 square plus minus 2 square plus minus 6 whole square, that is equal to 1 plus 4 plus 36. So it will be 41, root 41. So root 41 we have got, root 41. So therefore BC square will be what? 41. So similarly we will have to find, AC also. Okay, now AC is equal to C minus A, vector C minus A it will be. So it is 2 minus twice I plus J minus K. Okay, so AC will be what? Magnitude of AC bar. Okay, so it will be root over minus 2 whole square plus 1 square minus plus minus 1 whole square. So this is 1 plus 1 plus 4, that is root 6 we have got. So therefore SC square will be 6. So if we see the sides, we have found all the squares of the sides, side squares, isn't it? So we have seen AB we have got 35, AB square we have got 35, and BC square we have got 41, and AC square we have got 6. So here we can see that AB square plus BC AB square plus AC square is equal to BC square, isn't it? If I will put the values, let me put the value, 35 plus 6 will be 41, which is equal to BC square. Yeah, so it is following the Pythagoras theorem, isn't it? So if a triangle follows the Pythagoras theorem, if in a triangle this is satisfied, then we can say that the vertices are the vertices of a right angle triangle. So we can tell that the given position vectors of the points A, B, C are the vertices of a right angle triangle. Okay, so it will be proved like that. Is it clear? So you can write it like this also. Therefore the given points are the vertices of a right angled triangle. Okay, so position vectors of that points are the position vectors of a right angle triangle, you can write, or you can just write like this also, the given points are the vertices of a right angle triangle. So this is the proof. So we have done all the problems of exercise 10.2. so hope you have understood. Out of these problems, the questions related to direction cosines, questions related to unit vectors and section formula, these questions are important, and you will have to know how to find a magnitude and all. If you know how to find a magnitude, how to find the unit vector, how to find a direction cosines, then it is easier to do this type of questions. Okay, so we have completed the exercise 10.2. so hope you have understood. So if you like my videos, then please like, comment and subscribe. Thank you.